Okay, AP Statistics, Monday, April 6th. Let's get an update. Let's start with last week. Didn't hear back from you. I gave you a 0. So I did that this morning, Monday morning. If you do them, go back and do them. I will still change. No problem at all. So if you would do them, that would be great. These for the rest of April anyway, for the next couple of weeks. I don't know what's going on beyond that. My goal for these assignments is a quick little lesson, show you some examples, and then give you a few examples that are the same. That's what I'm looking to do. That's what I was told to do, and that's what I'm going to do. So it's made to keep our brains working, but not because of the communication problem, not a whole lot of depth. Okay, so you can still do those problems, do them. They're on confidence intervals, but we are transitioning. I want to start hypothesis test today. Hypothesis test. Okay, so let's get started. A hypothesis test starts with a hypothesis, and that is a proportion. We're doing proportions, so it's going to be a proportion that is a hypothesis. Now, depending on what we are talking about, it could be most anything. So like always, I try to keep things real and contemporary. So let's do this today. Let's say, this is all hypothetical. I have no numbers to back this up. Let's say that I'm trying to think of a realistic number. We'll say 5%. Let's say the theory right now from the CDC is 5% Americans have that is equal to 5%. Remember, that is a made-up number. I do not know. Well, even though it's a made-up number by me, as far as we know for this problem, it is assumed to be true. Unless there is evidence to overturn it, it is assumed to be true. So we're statisticians now, and we're going to test this hypothesis and see if the data can overturn it. Okay, we're going to work all week on, hold on. Sorry. We're going to work all week on the hypothesis test with the proportions. So we're looking for data that will say that this may not be the case. So I forgot to tell you, I am following along from the book. The wonderful thing as you study for your exam is the book has exemplar examples for each one of these types of tests that we're doing. So today I would like you to look at 456, 457, and 458, a little bit on 458. And that's what I'm using as a goal. I mean, I'm doing a different problem, but that's what I'm using as a format. Okay, so we've said that as far as we know, 5% of Americans have tested positive for coronavirus. Now we need, this is called the null hypothesis. If you noticed, it says HO colon P is equal to 5%. This is called the null hypothesis. Null I don't know if you'll be able to see this or not, but it says null hypothesis up here. HO, that stands for null hypothesis. Then after you have the null, you have an alternative. HA, alternative hypothesis. Now this is also P, but this is, and these could easily be questions on the AP exam, so listen closely to this. This is always equal. It always is equal. Now, when you do the alternative hypothesis, it can either be greater than, less than, or not equal to. Today, I'd like to stick with greater than or less than, okay? And say this, what do you think? We're probably more concerned with it being greater than that because this pandemic is kind of stressing us out. So we're going to say it is greater than 5%. All right? Everyone with me so far? This is the start. This is called, if you look, they break it down into parts, and this is called the hypotheses. No problem there. So we'll keep talking about this the next two or three sessions. P is greater, P is equal to 5%. That is the null hypothesis. And P is greater than 5%. That is the alternative hypothesis if the null does not work out with our data. Okay, that was the bottom of 456. Now, I'm not going to write these on the board, but I'm going to talk about them again. If you are going to be able to do a one proportion z-test, keep that one in mind. That's what we're doing here. A one proportion z-test. You have to meet certain assumptions and conditions about the data. If that doesn't add up, then you can't do it. So let's look at those and talk about them. I'm not going to write them on the board, but in theory, if one of these four were seriously broken, you wouldn't be able to do it. But we're going to be able to do it today. Once again, independence. Each sample is independent. The data was collected randomly. 10% condition, meaning the sample, I'll talk about the sample in just a second. Sample was not greater than 10% of the population. And then success failure, which is N times P and N times Q. Notice it is when I talk about P, it is the null P, not the sample P. And that will become clearer later on. All of those are greater than 10, okay? All right. I would like to say right now that the 10% condition is important for us because we don't want the sample to be too large. The success failure makes sure that the sample is not too small. All right, let's talk about the sample now. Remember, this is all made up, but we're talking nationally now. So let's make N equal to 100,000 people. It's just the sample. We're going to say N equal to 100,000 people. Okay? So we went out and we tested. You know, that's a big hot button issue right now is how do we test people? So we found a way to test 100,000 people. And of those 100,000 people, this is going to be P hat. P hat is the sample proportion, And the sample proportion was, we'll say, equal to 6.5%. I'm just making this up once again. 6.5%. Let's keep looking. Now we need to find a z-score. To find a z-score, if you look at 57 near the bottom, we need to find a z-score. And the formula for that is z equal to the sample proportion, p hat, minus the null, p null, p sub 0, over what? What is our new standard deviation? The square root of p, and I'm going to say not just p, but p null, q null over n. All right, that's our formula. Now we need to fill in the blanks. Let's find that standard error first. And let's do it. It is the square root of 0.05 times what? Q would be 0.95, divided by our n, which is a large. We're not used to, and the book doesn't usually have n's this large, but we're talking about the whole United States, so I'm going to do 100,003. I may regret it. I don't know what the number is going to come up. Yes, I am regretting it already because it is a very small number. Okay, we're just like the classroom. We're going to change that n because, I mean, you could still work it, but it's just such a small standard error that I don't want to. Let's change it to 1,000. So let's do that over again. We're going to do 0.065 minus 0.05, and then we're going to find that standard error again. Square root of 0.05 times 0.95 divided by 1,000. There is something a little bit more to my liking. It's still a very small number, but it's better than with 100,000. We'll call it 0.0069. 0069. Okay, so we're going to go 0.065 minus 0.05 divided by 0.0069. And I get 2z is equal to 2.17. 2.17. Now, if you're looking for a model to follow, I'm right at the bottom of 457. 457. Z equals 2.17. That is one z-score. How many z-scores do we know to get a probability? I hope you said 2. And how do we find that other z-score? Remember, with the normal model, you need 2 z-scores, and out here was negative 99, and out here was positive 99. So this is less than, this is greater than. What was the alternative hypothesis? Greater than. So our other z-score is going to be 99. 99. Okay? So now we need to come up with that probability. And let's talk about that for a second. The name for the probability of a hypothesis test. It is called p-value. P-value, whatever that probability is called P-value. So where am I going to look for the probability? How about normal CDF? So I'll go second distribution, go down to normal CDF, and put in 2.17 and 99. I got a p-value of 0.015. You know what? I'm kind of happy about that because that sounds like a reasonable probability. And I just made these numbers up. So isn't that so let's go back and describe the whole problem again. We said that the null hypothesis for how many people in America have tested positive for the coronavirus is 5%. The alternative is the data that we're looking to overturn is it could be higher. We might be concerned that it is higher than that. That's why we have p greater than 5%. Our sample is 1,000. We had 100,000. That was too high, made for a very, very microscopic standard error, which I didn't want. So we changed it to 1,000. Then we said when we went out and took a sample, it was 6.5%. And we want to know, is that significant? Is that sample significant enough to overturn the null hypothesis? This is getting dramatic here, I think. So maybe it could be dramatic. If you were a scientist for the CDC, it would be very dramatic this week, I can assure you. So what we do, we needed a z-score because we're trying to find out this p-value, and we took the sample 0.065 minus the null 0.05 divided by the standard error 0.0069 and came up with 2.17. And the other z-score, because it is greater than, is 99. Now comes the big dramatic ending here, and it is this, your decision. Are we going to overturn, are we going to, looking for the correct term, we are going to reject. That's the right term. I had a mental block for a second. Are we going to reject the null hypothesis, or are we going to fail to reject? A little terminology alert here. You never accept the null hypothesis because we already assume that that is true. It's only reject or fail to reject. And the next few lessons will hammer that out. So right now, I have a little rhyme for you. And this rhyme, you'll never, if you remember this rhyme, you'll never forget whether to reject or not to reject. And the rhyme goes like this. When P is low, reject HO. When P is low, reject HO. So you might say, well, what is low? Low is a relative term. And you're right. But what I'm going to say, unless you hear otherwise, low means less than 5%. And that kind of, I don't want to confuse you with the 5 up there, but that's something totally independent. 5% is called the critical value, or the alpha level, are two terms for that. And if it's less than 5%, you're going to reject. Is it less than 5%? Yes, it is. So my decision is to reject the null, reject the 5%, and accept that there is that it is higher. We don't know exactly how high. We can't really say that that is necessarily true because of the whole idea of sample variability. But we can say with confidence that the null has been rejected and that P is greater than 5%. Okay, so that's your first taste of hypothesis. I know that's a lot. We're bringing a lot in here today. But it's good. We've got to get it. And those of you taking the test definitely need to know what hypothesis tests are for the tests. So quickly, a quick rundown. You got the two hypotheses, the null and the alternative. You go through the assumptions and conditions. Then you find out your p-value using this formula, and then you make your final decision. And there's some other things in my next lesson I'm going to talk about. So what can we have you do to show me that you're working on this? Let's change things up just a slight amount, and you do it. Let's change the null to 6%, okay? The null is 6%. So with that, you do the rest. I'm not going to tell you the rest, 6%. We'll keep the n at 1,000, and we'll change. No, we won't. We will keep p hat at 6.5%. So the only thing that we will really do on this problem to change it around is to say that the null hypothesis is 6%. And then you go through and do the whole thing just like I did. That's ingenious. And we'll see whether you're going to reject it at 6% or not. Okay? So I'd like to, keep in touch with you like 3 times or something, 3 little video lessons this week. This is a really important point. So you work that out. Next time we'll look at the calculator too, how that helps you. Well, you should be able to figure it out, but this would help you check it. Okay, maybe I should have checked mine, but I will after this video. But we okay then? So that gives you something to do. The video's up to 22 minutes. I didn't want them to be really long, so I'm going to get off now. Keep in touch. Keep in touch with me and try to get this back as soon as you can and get those confidence level assignments into. Over and out.